I'm building a very simple pipeline just from S3 to Snowflake. So this is what you're seeing right here in the SQLake environment. We want to make sure something that's very complex is going to be very easy for our users. So what that means is that we're going to create a S3 connection, and then I'm going to have a staging table for my raw data to this connection. And this particular connection is really just connecting to my S3 environment here, which has some sample data, that's retail data, and that's partitioned to the minute. And so once I can set my retention rate for this one, for my staging table to 7 days or forever if I wanted to keep all of my raw data. And from there, I can create a job to start populating my my staging table. And so what I'm saying is I want to start from now, or I can choose from a point of time or from the very beginning. And content type can be any format that you can imagine. We support a lot of formats, whether it's Parquet or JSON, anything that you can think of out there, we can parse the data automatically. And I'm copying from this particular bucket that I just showed you into this staging table. So when I run this job, this is going to continuously run, right? So because it's going to start pulling data from the S3 bucket, and it's going to continuously read into my table, as you can see here. So this is actually a table. The job is populating this table continuously. From here, you can do discovery, data discovery, you can do observation, you can do data quality control, you can do many, many things that are in here. So this is the data that's coming in. I just downloaded it from that bucket. As you can see, it has like many different nested structures. It's really complicated. So Upsolver is really, we designed this so that it's super easy for you to parse all of this out for you, so that you don't have to manually figure out what the structure may be and try to map it to a table. So all the structure is inferred from the raw file here in JSON. And once the data is starting to write to this table, we also give you, so this is a table right here. If you click on each column, so we give you very easy to understand data demographics on what the distinct value may be, what kind of value distribution that you may be looking at, when it was first seeing these values, last seeing these values, what's the density of these events, et cetera. So each column will have that information for you. And also on the table level, we have information about the table as well. So this is making data discovery and observation very, very easy for the users. And this is all dynamically being pulled in. So as you can see, I'm not really giving this table a structure. That means that everything is dynamic. As you have new data that's coming in, this is a slow changing schema. All of this is automatically, like declaratively managed for our users, so that they don't need to really worry about all of these things. Okay, so getting the raw data in, super easy, three steps: connection, table, job, done. So now I have data staged. So now what are we doing with the staged data? So what I'm doing here is, so this should be like very familiar for folks that are in data. I have it in the data lake, something that came from the JSON file that's very, very denormalized. What that means is a wide table with everything in it. But I want to normalize it in the data warehouses so that I can have good performance. I can do whatever I want with it, right, in this data model. So what I'm doing right here is I'm creating these tables in Snowflake. Let me show you what they look like in Snowflake. So I went ahead and created these tables in Snowflake like this, and I'm going to basically normalize my data model from this big, wide, denormalized table into these orders table, subject area, customer subject area, and item subject area from all of this raw data, right? And now all I have to do is go ahead and create a job to load to these tables. So anything that changes in this my staging table is going to get reflected automatically on my target tables as well. So that's another way we see it. This is a declarative way of doing things. There's no manual work that's involved in all of this. Nothing will break the pipeline when things change. All right, so once these data, so I can say how they're being loaded. And once these things are being loaded, I can, in near real time, reflect all the fresh data that are in my normalized data warehouse environment. I have all of these things that are populated continuously here. Okay, so Upsolver is basically exactly once, so you don't need to worry about data quality issues. It's all exactly once processing, and it enforces strong ordering. All the data will come in order, so that you don't need to worry about reporting issues, data quality issues, all of those things downstream as well. All right, so now that I have, this is an example, it's basically a very simple modeling example, but I can do something that's a lot more complicated. What if I want to answer a business question, right? I don't want to do a lot of deduplication and all this stuff downstream. Potentially can have data quality issues. Also, it's very expensive to deduplicate and aggregate all of these things over and over again on very large tables, staging tables. So what I can do here is utilize our state store, like as we mentioned above, and be able to aggregate a lot of the data over time. So I'm doing a lot of aggregation here. So for this thing, I'm trying to get the performance per item. And the following data, I can do item observe. So if you are looking for, deduplication, I can do an observed, or I can deduplicate it by group by on the job level, right? So for the items, I'm just aggregating and do some sum, and then we provide basically 200 functions out of the box, so that you can do all of these calculations, aggregations without having to do your own programming. It's already there for you. So I can see item performance here. I calculated it. All of this is being populated in real time, so that I can get a view, like, and have dashboards on whatever on this, and observe all the things that are happening in near real time using these continuous jobs. Right. So the next example, let's get a little more fun and more complex. And what we're doing right here is, let me show you a diagram just so that everybody's easy to see here. What I'm doing here is having this orders data, which is, there's a lot in S3 that's coming into my S3 bucket. So those are all my orders data. I want to enrich my orders data with a stores data, and the stores data has the last employee that worked on an order in a store, and I want to know which employee worked on a certain order, last order in the store. So that's what the question that I'm trying to answer. The store information is coming in real time from Kafka, and S3 is the main data set that's coming in from a different source. So I'm going to join them, make a materialized view out of my Kafka topic, and join with my S3 data, and then write it into Snowflake. That's the refined zone. So that's what I'm doing right now. Let me just log in here really quick and show you what my Kafka topic might look like. And while this is loading, I'll explain how the code works. Let me see here. Let me go to my topic, and the sales info is the one that I'm working with. So while this is being loaded, I'm going to explain my code here. I'm just making a Kafka connection, very easy here. So I'm connecting to my topic. And then I'm going to create a table out of that topic. So like everything else, it's dynamic. As the topic changes, my table might change as well. And then I'm going to create a job that loads from this sales info topic into the raw table stage that I am loading. And let me see if, okay, so great. So here's what the raw data looks like in that topic. Let me find a store so that you know what the store data looks like right here. So this is the kind of data that I want to enrich my order data with. I want to see what the store is and who's the employee, right? So that's what I want to know. And then with the state store, over time, I can always find the last person employee at a certain location that worked on this particular order. And this is a materialized view that I'm creating from this topic, basically. And then once I have everything loaded, I have a sales info raw data that's created here. So this has my all of my store level data that's in there. And here's what's really cool. I'm going to get a Snowflake table, and I'm going to do a left join from so this is the order table with all of my data on the left. And then this is my materialized view on my right. I'm going to enrich this data with this data. And then I'm going to load it into a Snowflake table that I have created, which is orders by last employee here. And now you can see I know this first name, last name of this employee ID that worked on the order last, right? So this is how easy it is. It's a very complicated problem to solve, but we try our best to make it super easy. And I just want to say that with any of these templates, if you sign up, you all have the first preview of all of this. You have the templates and with the sample data in there, and then you can choose these templates to help you get started.